Hold on, let me do some self-promotion. And mute my fucking stream. Alright. Seems like enough introduction. Alright, what did I do when I was gone? A lot. A lot. Too much. I changed the entirety of the IR for the third time. Third time while starting this. And probably like the 10th time when you sum it up with my last attempt. So, I'll go over what I did last time, which the VOD's out, and I timestamped it. I think I implemented the repl and type parsing and like the function declaration parsing. Nothing to do with the IR yet, so the parser doesn't actually parse anything, it's just a no up. So what I want to do currently here, I'll go over what I changed. So I wrote a ton of stuff, like about this is where we stopped. We stopped here. I was reading this before. Let me just change the song real quick. I've heard this a million times. Okay. So right here, HIR is SSA-like, and it supports block expressions, and the AIR is strictly imperative with control flow graph. And yeah, control flow, I wrote this here. I was writing this. This is just a bunch of jargon. And I was writing this. B equals scope proc, scope blocks. This is the last iteration of the second version of the of the IR. So this gets put out by the parser. Yeah, so present 0 equals 1, break, compilation type. Yeah, HIR in short. The main representation from parsing to type checking, basically a flattened lexical representation of the source. That doesn't hold in the current design, but that's basically it. We'll do as much as possible optimizations wise before the next step. So it'll just do as much as possible. Yeah, so it will be in SSA form, but won't likely include all SSA optimizations. That doesn't hold in this iteration, but it will be able to do a lot of the optimizations that SSA does. No, it won't. It would only do dead code elimination. I'll explain after when I get to the IR. Why do I l-m.dev? Why do I say hello to the world? I don't wish to speak to everyone. Okay. Yeah, so short circuit operations will be desugared into if expressions. That's what I'm already gonna do. Yeah, guaranteed ops are constant propagation, hoisting out of loops, and then aggressive dead code elimination. And here, whole program constant propagation, and whole program dead code elimination. So that was basically the last HIR. And then I was sketching out some stuff like G equals this, IO main equals this. So this is just some lexical scoping rules. So this is at the top level. You can have instructions at the top level, and you can have yeah, so you can have instructions at the top level and defs in the middle. And basically, what HIR was supposed to be it was supposed to be a flattened AST, a flattened AST, and you can tell how that doesn't hold because you end up having expressions at the top level, which was fine. But then you also have things like the loop keyword opening a lexical block, which I'll get into after, which I don't want. This is a functional programming language. Everything is an expression. I don't want to end up with a million expressions. No, I don't want to end up with me trying to take these expressions and turn them into imperative statement based, because there's no statements in this language. Yeah, so this turns into IO main turns into a function, so it turns into a switch case. It'll be desugared into a switch case. That's how the pattern matching stuff works. Yeah, so case K equals this, and then this, add, and then break 2. Yes, it'll break with the current value into the switch. Yeah, so it will store locals per scope. This is what I was doing. So each scope, right? Let's say you do a v equals do, and you have some stuff, right? Stuff. And this code above will be in the whole universe scope, which will hold everything. Maybe module scope. And then v will equal do, and then do will open up its own scope, right? And then you have things like k equals something. And I'll put that right here. Let's say for some reason, we'll make this a loop. And a loop do. Yeah, loop do. Let's say for some reason that here k equals something is a pure expression, and you want to do some hoisting. So what you would do is you would pull out this and put it here, and pull this out and put it here. But then what happens is this k variable is bound to the scope of loop, right? And that doesn't make sense. You can't move variables around wherever you want, and since that there's no distinction of functions as the top level thing, everything is a top level thing, meaning you got to put the locals somewhere. So I decided to put the locals, like store the representation of the locals inside scopes. But that doesn't make sense when I want to move variables up above scopes. So what I decided is to make all locals module wide, and then these scope things will index into their little slices of modules of locals. So that was like where I got to with the last intermediate representation I was working on last stream. And yeah, so this is what I ended up writing today. Loop equals this, v equals pure up will transform into this. This poses an issue. The syntacticalness isn't preserved if the local is moved out. This means we need to split locals and scopes. That's what I ended up doing. Oh no, I'm being pinged. What? Okay, someone clipped me. Okay, I'll watch it after. Yeah. Solution. Locals aren't attached to scopes. That's basically what I could do, right? I could keep the old statement-based intermediate representation where it goes statement, 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 and there's no expressions, right? That's kind of the SSA way. So that's, yeah, so I could keep that, and then also make all locals separate, and then make scopes index instead of scopes holding the locals. And then I thought for a second, right? The whole thing, there's not a single statement in this programming language. If there's no statement, if there's no statements, I'm gonna be basically trying to emulate, like I'm gonna be eventually trying to translate expressions into statements on the fly, which that works for most things, but it doesn't work for things like block expressions or if expressions, or things with, yeah, like I said, the loop, right? The loop keyword. It would be so much nicer if the loop was just a node, and it had children, and those things could loop around the node, and all you have to do is move nodes from here to here, like, and that would unhoist it. Let's say you have like hold on, there's the camera. You have a loop here, and then inside the loop there's like an expression which assigns a variable, and that's pure, and you want to hoist it out of the loop, right? All you have to do is move it up. You can't really do that with the old strategy. And then you'd also be dealing with loops not being... Because a block is an expression, right? But how would you, like... Because if you want to branch back to a loop with, like, probably like a break expression or a continue expression, you would have to be able to reference that loop, and that means that loop has to be a scope, but then you don't want scopes to open up lexical, like a lexical scopiness. Anyway, it's a whole lot of shit. Basically, this whole thing is me shifting from an imperative statement-based of execution instead of just an AST tree. I'm doing an AST. This took me a long time to explain, but I'm doing an AST, and it makes sense. It makes sense because this is an expression-based language. It makes sense to use an AST. It makes sense with things like loops, if you want to loop over and over again. It makes sense with hoisting. It makes sense with constant propagation, but not really, since it's not in an AST immutable form. But we can leave that to the next IR. I know I walked back on saying this first IR has to do as much as possible, but that's not the case, because we kind of want to finish this compiler, and we have to make not even shortcuts. You just have to be reasonable. I tried to stuff everything into the first IR. So we just do what we can, right? This first IR is about semantic analysis. I want to get my types. So that's what I'm doing. This hoisting, I mean, I could just do hoisting in the second IR because that's got control flow blocks. Anyway, we'll cross that bridge when we get there. So here, we'll run passes. Yeah, so that's just separate. Yeah, passes. Yeah. So this first IR, the reason why it's so useful and so important is because we have to identify where closures capture variables and not capture variables. We need to declosurify. That's so important because we'll be dealing with partial application and everything. We'll be applying partially, and then we'll also be creating functions, and you'd want to like propagate the variable into the enclosing thing as a constant expression instead of just taking it. Hold on, let me move this again. Fucking hell. Yeah. So lower the yeah. So this is the thing. Loop isn't supposed to open a new lexical block expression. Anyway, yeah. So I got to here. What are we doing for time? How long's the time? Okay, 12 minutes. It took 12 minutes to explain what I did last time and what are the pitfalls. Yeah. Okay. Oh man, new IR. Yeah, like before, only AST like. All we really need to do is type check this shit. Stop trying so hard. So that's a personal note. To not ever do that again. So here, valid syntax. Yeah. So this is basically an expression. So it's an assign expression with a label to loop and break to that label and return 10. So this is a valid syntax. Break is an expression which evaluates to the bottom type, which is no return. Yeah, and here's an example. These two thingies, v equals something. Oh wait, hold on. Yeah, that makes sense. So these are two definitions for the function v. So v matching on nothing will return something, and then v matching on 0 will return 1. And then this will generate the below scope. So this is the universe or module scope. And then the function definition will create their own scope. So this is v, and then it'll desugar into a case match case, a switch case, and then we'll have these patterns. So matching pattern here to something, match 0 to 1. So that's it. And so I ended up here. I want to, with this stream, I want to fix my legacy module system. And then once I have that done, I can do the IR. And since the IR is nested, all you can do is just malloc a bunch. I'm going to malloc the whole thing. I'm going to just be spamming mallocs because I don't really care about freeing. I can do that, and I can do fancy arena allocations next compiler, but I don't really care about memory usage now. I'm just writing a piece of shit compiler to bootstrap it. Yeah, and I talked about that before. I'm only writing a Bootstrap compiler because I want to. I'm writing the Bootstrap compiler like shit because I want to finish it. Do a quick and dirty implementation. Anyway, I need to do the module system. Yeah, so this is the old API. Let me go to the old code and show you how it worked. So you can invoke the compiler with like, let's say like compiler file.ext, and here, so compiler file.ext, and then is this our extension? So you want to register the directory this file is in as a root, so you can find modules like this. Let's say like, yeah, module, and then file.ext. You would run it on this, it would scan the whole root, this is root, and then it'll be able to locate these module directories, and that's here. So it would register root where this file is located, and then slurp the file, which means just read the file. And what if you pass it a directory like root? It'll do the same thing, it'll register root as a root, and then it'll be like slurp equals true, which means search for all of these files. It'll just search for all of these files and scan them in. So there's two, so there's two modes. So you basically can just do file.ext or root. So you can either take in a whole directory or take in a single file. Regardless, both of them have like their directories get searched for modules. And that's essentially what I want to do here. Yeah, let me go to the IO. Where is it? Yeah, so this is the FS node T. This is what originally was a module. So you would have this, you would have roots and a node arena. I could have just done malloc, but this is just some premature optimization. Yeah, so let me go through how it works. So let me just, the easiest one is just register root. No, I can just do it here. Register root. So it'll register the root, it'll make directories, it'll search the whole directory, and then it'll search directories recursively. Yeah, it'll go recursively. And find all the files. And then all it would return these node T. Yeah, it would return a node T. Or yeah, so searching the directories recursively will place files into the files queue. And the files queue will have this representation. It'll be like, this is the file pointer, not the file pointer, file path, data, len, and a reference to the module in a I32 index, U32 index. And that's how you get the files. It'll just be a queue, it'll be ever growing, and we just loop over it. Yeah, new files added, it'll loop, parse a parse file. And you would end up with a bunch of these references to modules. Yeah, this is the FS node. And this is the underlying representation of the module. So this is a path of the directory the module's in. It'll contain its parent, it'll contain its children, it'll contain the length. This is the length, this is the amount of files. This is its short name. So let's say you have a module like main my module. How it will be main will have child my module, and its name will be named that, and then its fully qualified name will be main.my module. And that's how that's the short name, and then is source scanned, and then is main, so this is the main root. Yeah, so this is just some old legacy stuff that I want to really change, and instead of naming this like a generic node T, I want to make this a module in the IR, right? Because during the parsing step, modules don't really, after like semantic analysis, and then you can start lowering to machine code or another lower level IR, modules don't make sense, right? They don't make sense. All this is a bunch of symbols. So I can just integrate modules as soon as possible, like attached to the folders they're in. and then I can start like lowering as soon as possible. So this is the easiest way for me to do it. So I just want to end up re-implementing all of this stuff. So that's what I'm gonna do. I'm gonna re-implement the module system. I'm gonna re-implement the module system and then do the rest, which is the IR. So yeah, I'm gonna change how these things work. So I'm gonna take files. Okay, here are the files. Oh, I'm gonna remove that. God, it broke my fucking. You know, these things happen every stream. No, just keep dying. It's not dead yet. Okay, no such process. Oh wow, it fixed itself. How? Alright. Okay, it fixed itself. Yeah, all.h. So I want the node. Yeah, I'm gonna take this. I'm just gonna have these local. Okay, fine. Yeah, so struct file t, and I'll take these out. Fine. I'll write in the all header. I hate it. Like, this is the all header is the having an all header that encompasses everything in the project is what I use for some of my projects, like big C projects, like TCC, like Tiny C Compiler. They use this type of thing, a single header. That encompasses the whole program, and that makes things easier. So you don't need to deal with circular references, because I dealt with that. I tried to make things clean in the old compiler. I had one C file and one header file, and I ended up with multiple circular references, and that's what I had to get rid of because I fucking hell I really like. You know what would make my life easier as a developer writing C? Uh, One, it wouldn't be methods on structs. I mean, that sounds nice, but it's not really that much slower. What is the slowest thing in the world, and is what kills me all the time, is making a function, like adding a function to a header file. Like I can write the whole function, copy its signature, place it in a header file, and then that takes a certain amount of time. And then every time I edit the signature, I have to update it. That takes a certain amount of time. And that's just the most annoying thing. That's the one thing I'm gonna love when I do away with C and I finish my programming language, because I write a function, switch to a different file, and it will be there, right? That's so it's like the Go or V version, V Go or V like module system. It's super nice because you have multiple different files in the same directory. You write a function here, it's available in another file. So each module is comprised of an entire directory. And that's the way I like it, really. Because that's the way I write C, right? But I still have to deal with these fucking header files. So that's the number one time killer when I'm writing C. It's annoying. But you know, I'm gonna deal with that. I'm gonna deal with it until I get to C. Until I get to my other programming language. I'm writing right now. So file T and then a mod. Where is it? Where did I put mods? Okay. Yeah, module T. Okay, I don't need this compilation struct. Alright. No. God, this is such a mess. Whatever. Okay, mod ref T. Okay. So this is a file node. This is basically a module, so it's a mod T. So that's the path. The parent module? Do I even want to store that? Okay, I'm in mod T. So I like being shorter. Hold on. Hold on. Oh yeah, I love gen remover. Okay. Rmod t is parent, rmod t is children, u32 children length, and r files name and mod ref t, and IR module. So there is no IR module. This mod t is not just a thing on the file system, it comprises the entire IR for the module. So I don't need is main, is source scans. No, is this always set? Is this a legacy thing? Files had been read from this directory. Is source scans this slab? This makes sense. That makes sense. But I don't need it. I don't need it. I don't need that either. Okay, so path, parent, children, children length, R files. R files. That makes sense. Files. Yeah. Path, parent, children. So that's just our module. And then the module type. I think it should just... Should put this under disk. On disk. Okay. On disk. Can you do type? Can you do type defs in here? I swear, if you could. Huh. You can. Type def struct disk t. Disk t. No. Struct. No way you can do that inside types. I had no idea. It's still global, but it keeps things nice and neat, which I like. Wow, I had no idea. Yeah, I don't write enough C. I write a lot of C, but not enough, apparently. Definition of dist t conflicts with type def of the same name. Oh! Wow, okay, you can't do that then. Can you do this? You can. So on disk t. Okay. So this is on disk struct. IR module. Yeah. No. IR module. Thank you. IR module. IR. Should I just make this, Hold on. Size 48 bytes. What about now? Size 1 byte. Oh yeah, because that's the default ABI. You know what? I can just make this... An anonymous struct would bring everything onto the global. Okay, well, that's what I want. That's what I want. I'm not going to make it anonymous. So I just want on disk to be separate, and then I can have all my IR stuff later. Disk T on disk. Alright, fine. This is the on disk representation. And then what I want to have is the list of local variables. Because the locals are going to... Yeah, so there's no distinction between global... Well, there is distinction, actually. Where do I define global variables? Yeah, anyway. So I've done that. So this is the mod T on disk. Okay, I can deal with the IR stuff later. That's what I'm doing. And then file T is separate. Yep, so this is mod. Yeah, I don't need this. Yeah. IR local T locals. Whatever. It's IR stuff. Alright. So this is the stuff. I got file T and mod T, and I can basically just start copying things over. Mod T. Arrays incomplete type fs file T. Where? Oh yeah, here. Extend. Oh, this. What warning does that give me? In header file, right? What's ODR violation? I don't know what an ODR is. I read about it somewhere. I forgot. Probably read about it. Alright, fs file queue. Okay. And we need roots, so type. Root. Yep, I know I forgot that name. This is the root. We'll only have a couple roots. Roots T. Yes, roots. It's 8. Then fill that in for me. Thank you. So how did I do this? I want to get roots, fs node roots. So that's a reference to a node. Yeah, so that's a reference to a node. Let me think for a sec. Let me check chat even. See this? Let's see what's going on in chat. Come on. Nothing. That's good though. I got two viewers, which is nice. Anyway, I didn't really care about Twitch. I only care about VODs. Okay. Yeah. So the roots, roots. I think I just want to store a reference. Our mod T is a root. So register search roots is a. Let's try DP. No assertions. I'm just gonna be appending to the shit and let the address sanitizer pick it up. Yeah, so I don't want to register root. I want to. Okay, well, to implement that, we'll do this. Yeah. Root. Then I can start bringing in all this other stuff. You know what? This is probably copyright. I hope not. Yeah, register root. Alright, so the make directory with no parents. That's what I want to do. Where's this defined? Okay, I don't want this. I don't want this. There's no definition of that. No definition of that. None of that. I gotta get rid of these old definitions. T. So this is a make directory. Parents. We got no parents. What does bool read name do? Read name is always true here. But what about here? Read name is false. Where is read name? Read name's always true. So what does read name do? Oh, there's no name. There's always gonna be a name though. Yeah, so we need this bool slurp as well. That's the set's roots. Alright, make directory. Fs r node r mod t equals ref equals. Nope, I don't want to call that. I just want to call fs files here. Plus plus. I'll rename this to something nicer. Later. T pointer. Yeah, so I just set the normal stuff. Mod on disk equals disk. Name equals path. No, path equals path. Path mod dot on disk. Children. Parents. Yeah, parent equals parent. Yep. Okay. If read name, you'd always want to read the name, right? I think I just do it is main. Just seems easier. No, this is definitely copyrighted. Name. So equals. Fill it in for me. No. SV move. Name. Disk. Name equals. Yeah, SV move. Yeah, give me this. Wait. Yeah, okay, last path. That's why I want this one. I have an implementation of that. Let me just bring this back. Oh, no, maybe I don't even need to bring it back. Take this. Thank you. Find relative path of exe. Oh, this was a pain to write in my old programming language. Oh, and fuck this function. It's a dumb function. Yep, there's this stuff. Yeah, I'll just def them up here and then use them below. This is the most annoying part in the world. Uh-huh. Mod. Man. Mod on disk. Man. Yeah, now we're gonna use POSIX directories, which is so annoying. Dir equals open dir. Thank you. No. Right. If not, error without. Yeah, error without pos. And I just, I'll just steal this. Error no. auto import that mod on disk. Yep. U32. Let me just steal all of this. It's easier. I don't know why I'm writing it. Yeah, copy fix later. Okay, where's stat defined? Struct stat. Stat buff? No, it's incomplete. No, that's definitely copyrighted. Yeah, Aquanicism. Yeah, so I gotta get stat buff imported. I don't know where that's from. Here, this is stat. It's easier. Yeah, unknown type. It's T. Rmod. T. No. It's just our file. Yeah, struct file. I'll make an R file. Yep. And then this is in our file. No, rmod t. Like this mod. Yeah, redefinition of stat buff. Mod t. Rmod t. What's this? Verified only chat. What? How do I disable that? Chat filters. No. Chat appearance. Okay, thank you. Thanks, ankit. Alright. Rmod children. Children photo. No. Oh yeah, I love GNU extensions. ASPrintf. It's good. Right, let me just change all this to mod on disk dot. Make this FSR node T. There's something else. Is it mod T? An R push. I need includes SDBDS. Yeah. Is our extension. Okay, I need that function. I don't want to make this public, just expose a single handle file or directory inputs. And I'll make that here, I'll make that big. Yeah. So okay, this is what I used to name. This is what. Hold on. Let me make it a. Yep. Conflicting types. Where is this used? Static constable. Compile time constants. Constants always go above static defs. I'm not following any kind of style. Compile time constants always go above static defs. Okay, well, there you go. File extension. Sudo. Okay, perfect. Fix this. Not fix this. You know the hardest thing in programming is finding a name for your shitty project. Find name. Find name. Alright. Is our extension... Why is it still conflicting? Const. Alright, is our extension. Am I doing that right? Yeah, it's a constant. Have you learned Haskell? Okay, so my interactions with Haskell is just like my interactions with Rust. So, yes, your question. Have you learned Haskell, Liam, from ankit? So my interactions with Haskell is just like Rust. I write a lot of I write a couple programming languages: TypeScript, Rust, C. Oh no, TypeScript, V, and C, and then I like Python sometimes. And I look at these other languages from a compiler developer's perspective. So I look at Rust and I look at it as this technical marvel that's never been done before, right? But I don't use it. I don't use it because it's just I only really see it as a language you write papers on. You would never use Rust for something that you would just want to get done, right? Even if you want to write a DLL, you'd use C or something. But if you want to get something done, you wouldn't really use Rust, right? That's why I like V and stuff, because you can just knock out something, and it works. Anyway, I get to my point. I look at languages that are really extensive as just things that I can look at with it, look at 10 feet away and read papers on, and go to their playgrounds on the websites and write code and look up the binary output. That's what I do for Rust. I do that for Haskell as well. Anyway, I looked at Haskell a couple months ago, and I didn't even have to write it. It just changed my whole perspective on programming in general. I didn't even have to write it. I looked at it for a second, and my mind was blown. And now I'm redesigning my entire language, my imperative programming language, to be a functional language. To merge the best of both worlds of imperative and functional, but while staying 70% functional. Yeah. So yeah, my thoughts of Haskell is that it's I haven't learned it, right? I haven't learned it. I know some decent stuff. I know how monadic IO works. I read the paper that Simon Peyton, the creator of Haskell, wrote. I read the paper about monadic IO and how we solved problems with the first Haskell and the new one. I haven't learned it, but I know decently how it works under the hood, and how its syntax works as well. If someone told me to write a program in it, I'd fail. Well, I wouldn't fail. I'd just read online. It'd take me a long time, but I know how it works enough. It's a really interesting programming language, especially with its lazy evaluation. But when I'm writing this language, I rip out things. So I'm ripping out lazy evaluation. I'm ripping out monadic IO, and I'm opting for a more guarded imperative style. So this is basically just going to be the C Haskell, this programming language. Yeah. Sorry, I went on a tangent. Sorry. Alright, let me get this done. Slap file with size. So this will just read a file. It's interesting. I didn't realize we're modeling off. Yeah, it's not entirely. I'm changing the syntax a little bit to make it parsable context free. Because when you parse Haskell, you need to know about peak tokens and stuff. You can't parse Haskell context free. So I'm making some alterations. Let's say you want to define a function. You make this function so vk equals k plus 10. So this is a function in Haskell. And then and then in this language it'll be vk equals k plus 10. And now when you get to here, when I write compilers, I always have a single token and then a peak token. And it's bad practice. You know, I just want things to be easy, right? So I get to here, I get to the identifier v, and I know this is my current token. I know that my peak token is this colon. So I know this whole thing is a function declaration, and then I can go to the next token and say, okay, I can parse my pattern matches, and then I can keep parsing pattern matches until I get to an equal sign, and that's the rest of my function. That's how I do it. Yeah, so I'm modeling it. I'm modeling it after Haskell. Like not like everything. I've written so much about what I'm gonna change in Haskell. Specifically, its ability to do imperative stuff. Right. Let's say you wanna like loop imperatively and mutate local variables. Right. If it doesn't transmit that to the outside, it's still a pure function, right? So you don't. I really don't. I don't want to. I don't want to program with Haskell's restrictions of non-mutable data, right? Because I can use mutable data inside a function while it's still being like functionally pure. So that's what I want to do, right? I want to introduce like mutable variables. I want to introduce like how in Rust we have to pass things as mutable, and then in V as well, when you pass a parameter that gets mutated, you have to explicitly put a mut in the front. And basically combining everything to make it a super readable Haskell, which is as fast as C. And that's basically my end goal. That's what no one has done before. And that's usually usually if someone's done it before, I just scrap the project. So, this is a long-term thing for me. I'm eventually going to end up doing. Yeah, so it's going to be modeled after Haskell in my image, how I like it. Alright, take all of this. Yep. Memmap. Open. Right. Close. Yeah, no assertions. I'm just gonna let the static analyzer find it. Not static analyzer. Address sanitizer find it. I'm not bounds checking at all. Was it FS? No. T pointer. Mod equals mod. Should I add map populate? No. Alright, so I just mem map the whole file with prot read. It's the fastest way. Uses less system calls. Yeah, so slurp file with save size. That gets called here. What doesn't get used? I have a question. When setting up your build pipeline, do you use a specific compile time tool chain? You mean like CMake? Oh, like, yeah. Do you mean like CMake to set stuff up? Yeah, your question was random question, but when setting up your build pipeline, do you use a specific compile time toolchain from ankit? Yeah. So yeah, you mean like CMake? So I despise CMake and everything. I even despise make. Like the worst, like the most I'll ever do is write a nice make file, and then even then, like I all I want to do is like, okay, glob all the C files, and then glob all the H files, and then combine them all together with the rules. That is so hard in make. That is so hard when using make. It's not like, it's not hard. All right, you can find out the answer by going to Stack Overflow for like 2 seconds, but it's just it's just, why does it have to be that hard? And I looked into other things like Ninja, like the Ninja build chain, and I read a little bit, and I read the line that said Ninja files are supposed to be generated by CMake or other things. Why can't someone just make a simpler make? And that probably exists, right? But then I look up, I can't find anything. Yeah, so when it comes to build chains, like when I want to make something like and I'm making like a big project, I'll just use makefile. And when I pull in something that's CMake, I inspect what the CMake does and then copy its commands into the makefile. That's how much I despise CMake. Yeah, 90% of those build chains are just exotic versions of CMake. Yeah, that's right. I don't get why they can't make a simpler one. But yeah, I'm always using make. I rarely write scripts, shell scripts. I just use make files. I mean, my current build script right now is just gcc glob all the C files and then just run the file with a.app. Because it just compiles fast enough anyway. Incompatible pointer types. Oh yeah. Wait, what? Let's make directory. Okay, node arena. Oh yeah, I don't have a other one. FS. Not node, mod. And it's not a queue. $128 modules is enough. Alright, incompatible pointer types again. Yeah. Wow, I'm surprised that's just a warning. These are files. Did I not put that? These are files. No, just files. Files. No. It's easier to read. Yeah, children. Mainland children. Okay. And that makes sense. Yeah, I'm removing all these old comments. Yeah, leaks are okay. Yes, leaks are okay. Alright, so I have make directory, so I want to set entry root dp. I don't know what I named that. Register root. Okay. Yep, R mod t fs make. Where's it? Why can't I? Equals. Why is this defined? Yeah, so I don't use this. I use this. Why is that false? Hmm. Why does that pass? Why is it pass false? Yeah, I'm going through legacy code right now. I'm just trying to remember what I was thinking 6 months ago. Oh. Hi Liam, sorry I got to go. Alright. Bye Ankit. Thanks for sticking around. I had a lot of things to say about those questions. Thank you. Alright. See ya. No problem is pretty interesting. Yeah. Yeah, it is. I'll be making a ton of these. Next. Let me know when you're going on next, and Kiddo too. Next. Yeah, I will. I will let you know. Who's this? Inquation. I don't know where you came from. You probably found me, which is nice. I saw functional programming language as long as it's not Haskell. Well, you're in for something. Uh, all I can say, is that it's Haskell like you've never seen before. So hopefully that counts for something, right? Hopefully it counts for something. You'll see. You'll see. If you want me to explain to it, just explain. Just ask again. I explained to Ankit over here. Anyway, I'm working on the module system. Yeah, I wanted to read the directories lazily, not spam it over and over again. Reader. Yep. FS make directory. So I want the children to be stubs, where I can search the directories again. Okay, I don't need any of these. These things need to go. Where's our file? Our block T. No. How am I gonna represent the stubs? Yeah, this is the most important thing right now, the module system. I do the module system, that's work I don't have to do a couple months into the future. Let's see. So we're an hour right now, which is good. I can get the module system done by then. Disk T. Is stub? It's stub. And then, yeah, if it's a stub, the current module is needs to be set. Yeah, but this is stub outside of disk T. And that's the first thing you check. And I'll make a function to construct a stub anyway. Make stub. And then I'll add its FP. Yeah, I don't like this being named P. FP, and then DB for path. Directory path. Yeah. This saves a lot. This saves a lot of time if I do it this way. Make new file. Nope. Let's make stub. And this returns a r mod t. Parent. That's just the parent. Directory path, right? I didn't put parent here. Okay, yeah, so it's just is stub in this path. Yeah, so is stub. Mod t equals yeah, just create it for me. No. Oh wait, no, r mod. Yeah. Yep. Mod on disk. This stub is true. And this path is this. Yeah, return. Okay, we'll have to install the ID. Yeah. Make stub. It's gonna be doing with all of this. Yeah. Was it concat name? Yep, and then parents. So make a stub. Lazily loads and source path. Yeah, just do it lazily. Yeah, and I'll just read the files. Sure. Yes, lab file with size. Good. Set entry. fs make directory. Yeah, there's no need to have the slab thing. Slab file with size. You'd always want to do that. In what world where you wouldn't? Alright. I can make that separate. Okay, yeah, so always slab. Yep, so entry root. fs make directory, dp parent is none, bool is true. That's main. Okay. Register root is main. Yep, is main equals true. is main. Fine. This makes sense. Oh, wait. Yeah, this makes sense. I'm gonna go back to it. Yeah. Okay, thanks. Thanks. That's really nice. Uh, well, ext, so is main true, slurp false, is main true, slurp false. Man, if I ever get to programming like this, wait. LAJXJDNE says, man, if I ever get to programming like this, I swear to God, this shit looks absolutely insane. What are you working on right now? Okay, I'm working on a compiler for a functional programming language. So I'm working on the Bootstrap compiler. This is written in C. And it's for a functional programming language. So it's like Haskell, but it's nothing like Haskell. Sorry, my main got banned. This is Lachlan from the HSFP. Oh, hi. Okay, that's alright. Yeah, I didn't know who you were initially. Alright, well, feel free to ask questions, because I'm here all night. Not all night. I'm here for another 30 minutes. Yeah. Oh, it just returns it. Return. My friend who's doing CS was programming in C. It looks like such an insane language to program in. No, not really. This is what I tell everyone. This is what I tell everyone, like, who wants to learn C. C has like 20 keywords. It's like one of the simplest programming. It's not simple. It's like simple. It's got simple building blocks, and you can build big things. But you have to work with memory. It simplifies things so much that you have to work with memory on a low level. What's it say? Is this for V? You said it was a programming language, so I'm assuming this is for V. No, it's not for V. This isn't a project for V. This is a personal project. I've always wanted to create a programming language, and I can do it now. I got free time, so I'm working on it. Oh yeah, and that C explanation could have gone better, but if you want me to explain more, you can just ask. It's alright. Mod equals this. False. Yo, average school holidays free time W. Yeah, that's a W. That's a W. That is. Alright, spacebar. I'm pretty sure I've heard of pointers which are used in C to store variables completely in memory to reference. Yep. Every variable has a position in memory. You can take it as address, and that address is just an integer. Let's register root. Oh, okay. Alright, so register roots, that's basically the same thing. Main, slug file. There's mod. FP mod. And return mod. Alright, set entry file. Set entry roots. Roots. This main is false. Do you want to read innards? No, that's always false because this is a root. Yep. Alright, register root, set entry root. Okay. Lab directory. No, there's no need for that. I think that's it. I think that's the whole API. Except for this, like, locate node if you're ever going to import stuff. Those roots. Okay, roots is inside. A root would always be here. Roots, FS roots. No, FS roots. Yep, assign a root. And this entry root as well. Yeah. Yep, assign root, return mods, register root is the exact same as this file, this thing. Except you want to set slab to false. Both these false. So it's not main and it's don't read the innards and then assign root. Done. That's easy. That's the easiest thing in the world. FS slab file size. Can you even do that? Can you return a void? Wow. Okay. That's the easiest thing in the world. Okay. I'm done. I'm done here with this thing, so I can remove search root, set entry file, register import. Register import's a tricky one. I'm gonna have to do that later. I get imports working. What time is it? It's 12. 12:20. 12:26. Alright. Remove all of this. No. So register import. I don't want to get a link error. That's like the last thing I want. Okay, so all of these underscores. Yeah, I don't know why these are underscores. This is like a STB thing. No, it's more like a so-called thing. FS slab file, register root. Just steal all of these. Just copy the whole thing. Yep, just delete it, delete it, delete it. I hate writing declarations. Let's slap file. I'm just getting called from. Yeah, okay, this is gonna be slab file is gonna be local. Yeah. Mod as well. I wanna get FS mod arena. No, it's not a stub. No. On disk files count plus plus. Fine. Plus plus. So register root, register set entry file, and set entry file. That's all. That's all. Register import. Perfect. Let me put this register root and put that thing above. That is the whole implementation, really. I'm gonna take all of this. You have to make this public, blah 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 blah. Yeah. No, that's right. No, that's right. Let me follow this to-do real quick. Set entry arg v. Hard pointer. Just hard pointer. And all I'm gonna do is emulate the stuff in here, so that means I don't need to move it up. I don't want to make these two functions public. Yeah. RModT. Slab file. Yeah, so I'm basically just gonna be calling these FPLC roots. Hug P. This is it. This is it. FS. Head entry root with hug P. Wow. Oh wow, this returns an RMod. Yeah, I don't. This is supposed to be void. Alright. Finally, clean code. Wait a minute. And I can just take all of these. Moves to all.h. Where's the fs? Okay, yeah, I can get rid of all of this. Q, steal that. This extern. Ready. FSR node T. FSR. Cool. Okay. Alright, our mod T. That's your mod. Just move you over. Your face is in the middle. Alright, this looks good. Make that FS. Look at all this, look at all the Git shit. Anyway. There's entry, there's main. Alright, I'm sorry, I have to do away with the repl. Oh, can I keep it? I say I keep it. I say I keep it. What did I do with the repl? Yes. That sets the entry. Sets entry repl. Yeah. Must set. Must register roots when needed. Alright, then I can implement this then. Let me go further down. Even further. Oh, this is far. Okay. Alright. Entry repl. So you have to set up your own routes as well. Your own routes to search for stuff. It'll be basically equivalent to set entry file. What's current working directory? Alright. Get current working directory in C. It should be oh yeah, get CWD. Where's path max? Is that like what's the GNU extension? Man get current get CWD. All right, where's the GNU extensions? Oh, get current dir name. Where's this from? Yeah, this is a GNU source. Trust me. That's not how you spell source. Let me just make this whole thing a GNU source. Redefined? Where was it defined? Is this always a GNU source? Fine, you can get your GNU source here. Actually, I don't think it's even needed. Get current name. Yeah, please, malloc. Where's this defined? Where is this defined? Uni std. Oh, it's already here. I think I need a GNU source then. get current dir name. Oh, if def use GNU. Features.h. Do I need to include use GNU? Oh, it's this. If def. Please remove. Maybe, is this an error without it? Okay, it's an error. Alright, use GNU then. Const child pointer p. Okay. Things getting longer and longer. EP. Set entry raffle. Okay. Will register current director. I'm just lazy. I want to keep all the impl. I just want to keep all the stuff inside. Anyway, rmod. Is main? Yes, but don't take the files. Okay. Return mod. No. What else did I do? And I'd want to add. I want to add a file to it. Mod p. Make this ref. Mod t. Let me just mod per. And fill that in for me. Mod per. Files count plus. Add another file. Add another file, and then what else? Then just make a new file. All right. Our file. Make a new one for me. No, it's not how that works. What's it called? fs files arena let q len, and then lt. Fill that in. Initializing file. Oh, alright, equals file t. Data equals to be filled in later. Len to be filled in later. File path equals. What's the file path? Repl? No. This is to be assigned later. No. Mod equals mod. Path equals st, not stdin, it's repl. File. This will return a reference to file. Will register current directory. That thing as before and bring us all the way back up. All.h, bring me that back. Or just the current directory. Sure. Set entry repl. Yeah. Alright, and then in main I can fuck all of this other stuff off. Alright. File t equals file fs file per. No. Okay, and then remove all of this shit. Okay. If repl. Okay, let me assign it proper command line arguments. If argc equals 1, repl void repl. I'm not extracting this from another function. Alright. Repl else usage. And file and sure. So that's repl, which means I need to use the files that I got before. Set entry repl r file t repl equals file t repl per. Okay. And only thing you need to change is that repl. Oh, okay, it's already got repl. Sure. Yeah. To do import q construct large module HIR. Of course. I need to handle the queues. Import q. That's fine. And all I need to do here is fs set entry argp to argv 1. Yep, argv1. That registers the root. To do register lib. Do that later. Okay, and this will set the entry queue. How this set jumps over and over again? Okay, well I only need it once. Return 1. No, that's UMG. That's gonna fucking claim me. Alright. Yes, that sets error. It's to do error, whatever. FS set entry argp. Yep, that's the import queue. R5T. The entry. Parsing file. Perfect. Still the old I as well. No. S files qlen -1. Okay. This makes the most sense. I'll leave FS dump tree till later. It's an hour 40. But this is good for now. Really good for now. Rename that to FS. Let's just see if we can build GCC. Will I get linker errors? Unknown FS unknown T. Alright, well this is basically our mod T. Yep, replace. And this is basically our file T. And replace. Unknown type name scope T. Okay, I leave this for later. How do I get everything except the parser compiling? Okay, I'll just delete it. I'll rename it. I'm not deleting it. Okay. Okay, this is just some errors, old errors. Other than that, these all compile perfectly. It's good. Alright. It's the module system. What do we write now? Git log. This is init. What is it? Module. Man's DMing me about Twitch at 4:07 AM. Who is this? Abusing this goose? A business goose. Who are you? Better not be S. Mod. Okay, it's the third stream. What do they do? Yeah, FS, so implemented. Okay. Revamp. Rewrite entire module system. Rewrite and simplify entire module system. Done. That's it. I'm out of here. Wait, I didn't try it. I didn't try it yet. Hold on. I didn't try it. Let me just delete the parser real quick. And fuck the P entry. This P entry. Let me just define it. No, it doesn't. Collecting types for P entry. Okay, fine. R file T, and then nothing. Alright, GCC run. Okay, you know what? Fuck, I'll do this later. I'll do this tomorrow. I'll clean up the code tomorrow and write some boilerplate. So when I get into stream again, I'll be more directed. Anyway, that's the entire module system done. So why I needed that to be done? Many reasons. One, it's stuff I don't need to do. If I do the module system now, I don't need to do it in 2 months. And it'll work with the intermediate representation, the like AST, HIR stuff. So it'll all work together. And I also needed to update the module system to work lazily, right? How it worked before is that you would point it at a root, and it would recursively scan all the directories, but not scan the files. It'll scan all the directories. But, I mean, why make that distinction between files and directories when you can just scan a directory for files and then mark those as stubs, and when you start importing, it then brings in more things. So it's lazy. So you index the directories, but you don't index the contents. But only when you import, you index the contents. That's basically what I wanted to do. Anyway, this module system is a lot like Go and V. It's a lot like V, and that's what I like. So that's what I'm going to end up with in this language. And that's all I needed done. So I do this, tomorrow I come back, I implement the HIR AST thing, and it's all done. And okay, alright. I'm gonna go to bed. It's bedtime, what time is it? It's 1. Alright, good night. Good night, everyone. Good night, good night, good night, good night.